friends, in the last session we have started a discussion of probability, in which we have discussed so far different techniques which are used for calculating probability. Now, in this part of the program, first of all I would like to discuss two different theorems used for calculating probability. After that, I will be touching upon what is sampling methods. Then I would like to discuss what is hypothesis and null hypothesis. Then we will discuss in detail what is test significance, in which I would like to discuss the test significance for attributes, for large samples, for small samples. Then I would like to discuss three parametric tests, that is t test, z test and f test. And finally, we will testing the non-parametric test. This is called chi-square test. Now, first of all friends, I would like to discuss the two theorems which are used for calculating probability. The two theorems are the addition theorem and second is multiplication theorem. Now, according to the addition theorem states that if two events A and B are mutually exclusive, the probability of either A or B is the sum of the individual probability of A and B, or we can say that this theorem applies only when two events are mutually exclusive. Now, how will you calculate probability according to this theorem? Probability of A or B is equal to probability of A plus probability of B. Now, this can be extended in case if there are three or more mutually exclusive events. Now, in case of more than two events, then this theorem can be extended in this manner. Probability of A or B or C is equal to probability of A plus probability of B plus probability of C. Now, we discuss a problem which is framed in this connection. Problem on calculating probability under addition theorem. The managing committee of Vaishali Welfare Association formed a subcommittee of 5 persons to look into electricity problems. Profiles of these 5 persons are male age 40, female age 27, male age 43, male age 65 and female age 38. If a chairperson has to be selected from this, what is the probability that he would be either female or over 30 years? Now, we discuss a problem which is worked out in this manner. P female of or over 30, P that is for probability, is equal to probability of female plus probability over 30 minus probability of female and over 30. In this way, 2 by 5 plus 4 by 5 minus 1 by 5 is equal to 5 upon 5, and that is equal to 1. Now, what happens if events are not mutually exclusive? If both events are possible to occur, then it is regarded as events not mutually exclusive. The addition is modified to calculate probability in modified form of addition theorem. If events are not mutually exclusive, then we require modifications in respect of addition theorem. Now, in this case, the theorem is applicable in this form. Probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Now, probability of A or B is probability of A or B happening when A or B are not mutually exclusive. Now, probability A is equal to probability of A happening and probability of B is equal to probability of B happening, and probability of A and B is equal to probability of A and B happening together. Now, in case of 3 events, then what will the addition theorem? P means probability of A or B or C is equal to probability of A plus probability of B plus probability of C minus probability of A and B minus probability of A and C minus probability of B and C plus probability of A, B, C. Now, we discuss a problem which is based in this connection. A person is known to hit the target in 3 out of 4 shots, whereas another person is known to hit the target in 2 out of 3 shots. Find the probability of the target being hit at all when they both try. Now, we discuss the problem. The probability that the first person hits the target is 3 by 4. The probability that the second person hits the target is 2 by 3. the events are not mutually exclusive because both of them may hit the target. Now, probability of A and B is equal to probability of A and probability of B, since A and B are independent events. Now, the required probability is 3 by 4 plus 2 by 3 minus 3 by 4 multiplied by 2 by 3. In this way, we calculate 17 by 12 minus 6 by 12 is equal to 11 by 12. Here we have applied the theorem P of A or B is equal to P of A, means probability of A, plus probability of B minus probability of A and B. Now, we discuss the second theorem that is used for calculating probability, and that is multiplication theorem. This theorem states that if two events A and B are both will occur is equal to the product of their individual probability. Symbolically, if A and B are independent, then P probability of A and B is equal to probability of A is multiplied by probability of B. Dear friends, this theorem applies only when events are not mutually exclusive. Now, this theorem can be extended to 3 or more events. Now, we discuss a problem which is based in this connection. A man wants to marry a girl having qualities white complexion. The probability of getting such a girl is 1 in 20. A handsome dowry, the probability of getting this is 1 in 50. Westernized manners and etiquettes, the probability here is 1 in 100. Find out the probability of his getting married to such a girl when the possession of these 3 attributes is independent. Now, we discuss the problem. Probability of a girl with white complexion is 1 upon 20 is equal to 0.05, and probability of a girl with handsome dowry is 1 upon 50 is equal to 0.02, and probability of a girl with westernized manner is equal to 1 divided by 100, we get 0.01. Since the events are independent, not mutually exclusive, therefore, the probability of simultaneous occurrence of all these qualities is 1 upon 20 is multiplied by 1 upon 50 is multiplied by again 1 by 100, and that is equal to 0.05 is multiplied by 0.02, further is multiplied by 0.01, and that is equal to 0.00001. So, dear friends, we have discussed the 2 different theorems which are used for calculating probability. Now, we discuss the sampling. Sample is a device of learning about large masses by observing a few individuals. Whenever we have to learn about the masses, then it is not possible to study individually, then we have to take up some samples out of the masses, and the sample which has been taken for this purpose by the investigator is regarded as sampling. Now, sampling theory is a study of relationship existing between a population and samples drawn from the populations. Now, whenever samples have been taken, then we have to have the intense study of the sampling so as to establish the relationship between sampling and population. Now, we should know what is population. A universe or population may be defined as an aggregate of items possessing a common trait or traits. Now, whenever we have to take the samples, then these samples are taken from the population or universe. Nowadays, it is better that we should use the word universe in place of the population. Now, types of the population. There are 2 types of the population: finite population. Now, number of items is determinable. It means whenever we choose the population and numbers are quite determinable, relatively not very large, then this is called the finite population. And second is infinite population. The number of items cannot be determined because population is very large. Now, this is regarded as infinite population, and in this case we can say the size of population is very large as compared to the finite population. Now, what is sample? A word which literally means a small universe. Whenever we choose some items from the universe, that is called a small universe, or we can say sample so taken from the universe is regarded as the small part of the universe. Now, sample means that is consisting of a small collection from some large aggregate about which we wish informations. Whenever we are interested to find out information in respect of large aggregate, then we have to select, we have to choose some samples out of that. The samples so taken will be taken into consideration for further study. Now, what are the methods of sampling? There are two methods of sampling. First is random sampling or probability sampling. Now, probability sampling methods refer to those in which every item in the universe has a known chance. It implies that the selection of sample items independent of the investigator. Now, in case of random sampling, the sample so taken is quite independent from the investigator, or it is not quite subjective either fully or partially. Now, in case of non-random sampling or non-probability sampling, it refers to those which do not provide every item in the universe. The selection process is partially subjective. Now, in this case, the investigator has a vital role to play, and he has to select the sample according to his requirement, according to your, we can say, needs. Now, probability sampling methods. What are the methods which are used in this case? Simple or unrestricted random sampling. Second is restricted random sampling. Now, in this case, there are further methods used, that is stratified sampling, systematic sampling and clusteral sampling. And in case of non-probability sampling method, we use judgment sampling, quota sampling and convenience sampling. Dear friends, we have discussed what is sampling and what is sampling methods. Now, we discuss what is hypothesis. Hypothesis means an assumption that is about a population parameter. Whenever we proceed for research investigation, definitely we have got some assumptions regarding population, and that is called hypothesis. A statistical hypothesis is simply a quantitative statement about a population. For example, a coin may be tossed 200 times and we may get heads 80 times and tails 120 times. We may now be interested in testing the hypothesis that the coin is unbiased. Now, we discuss what is null hypothesis. It asserts that there is no difference in the sample and the population in the particular matter under consideration. Now, null hypothesis refers to whenever samples are taken from the universe, then we can assume that there is no difference at all, population and the samples taken. For example, whether a particular drug is effective in curing malaria, we will take the null hypothesis that the drug is not effective in curing malaria. The rejection of null hypothesis indicates that the difference is statistical significance, because our null hypothesis is rejected. The acceptance of the null hypothesis indicates that the difference are due to chance, whether we can say that the drug is not quite effective. Now, we discuss the test of significance. Test of significance occupies an important position in a statistical test. Now, in significance testing, two types of problems are faced by the investigator. First is comparison of two samples. When samples are taken from the universe, then we have to see what is the significance of the two samples taken from the universe. At the same time, comparison of samples and the original population. After that, investigator may be interested to test the significance of samples along with the original population from which samples have been taken. Now, first we discuss test of significance for the attributes. In case of attributes, presence or absence of a particular characteristics is found out, or we can say whenever we go for test of significance or attributes, then there is definitely information is not given in quantitative manner. We just go for the qualities, the characteristics, whether it is present or absence. Now, there are so many tests which are used in this connection. First is the test for number of successes, test for proportion of the successes, and third is test for difference between proportions. Now, second is test of significance for large samples. Now, first of all we should know what is large samples. Large samples means that is consisting more than 30, then this is considered as large samples. It is difficult to draw a clear-cut line of demarcation between large and small samples. Normally, sample is regarded as large only when its size exceeds 30. Now, concept of standard error is used for testing the significance of the statistic in case of large samples. Now, standard error is used for testing significance in respect of the large samples. Now, we discuss the formulae which are used for standard error for different statistics. First is standard error of mean. For this formula is used. When standard deviation of the population is known, then this formula is applied. Standard error of x bar means actual mean is equal to standard deviation of p is divided by root of number. Now, standard error of x, that is for standard error of mean, and standard deviation of p is equal to standard deviation of the population, and n, that is number of the observation in the samples, or we can say total number of samples taken in case of calculating standard error of mean. Now, second is when standard deviation of the population is unknown, or we can say when we do not find the standard deviation of the population, then definitely this formula is highly useful. Standard error of x bar is equal to standard deviation of sample, and that is divided by root of number, or we can say that in this case we have to depend on the standard deviation of the sample, and that is to be divided by the number of the total samples, but we have to find out the root of the numbers. Now, in this case, this is very important that standard deviation of the population is preferred for calculating standard error of mean. Sometimes what happens, we may be given standard deviation of the population and standard deviation of the samples, but it is worthwhile, it is suggested that we should go for standard deviation of the population rather than the standard deviation of the samples. Now, second is standard error of the difference between two standard deviations. Now, standard error of standard deviation minus standard deviation 2 is equal to standard deviation 1 square divided by number is multiplied by 2, and that is number 1, plus standard deviation square of 2 divided by 2 is multiplied by n, that is for 2. After that, we have the root of this sum or total. Now, second is test of significance for small samples. Now, this formulae we are used for calculating significance of tests in respect of large samples, but how to have the test of significance for small samples? Now, test applicable to large sample does not hold good in case of small samples, or we can say what are the different methods which are used for testing the significance of large samples cannot be used, cannot be repeated in case of small samples. Now, what is small samples? Size of sample is considered as a small if number of samples does not exceed 30, or we can say when size of sample is 30 or less, then this is regarded as small samples. Now, in this case we have to use the student's t distribution. The t distribution is used when sample size is 30 or less and population standard deviation is known, or we can say that t distribution is parametric test, and that is applicable in respect of small samples, and that is highly useful when we have the standard deviation of the population. Now, how to apply the t distribution? The test the significance of mean of a random sample. In this case, this formula is used. T test is equal to x bar minus m, and that is further multiplied by root of n is divided by s. Now, here m stands for the actual mean of the population, and stand s for the root of summation of d square minus n, and first we calculate square of d, then it is multiplied by n, further it is divided by n minus 1, then we have the root, and this is regarded as s, and d stands for deviations of the assumed mean. Now, this formula is used for testing the t distribution. Now, second is test difference between mean of two samples. In this case, the t test is applicable. In this case, t is equal to x bar minus x bar 2 divided by s, and this is multiplied by n 1 is multiplied by 2 divided by n 1 plus n 2, then we find the root, and the root that we find is used to multiply the, we can say, result of x bar minus x2 divided by s. Now, here s means the combined standard deviations. Now, we discuss the test of the significance of the correlation coefficient. Professor Fisher has given a method of testing the significance of the correlation coefficient in small samples. Now, under this method, the coefficient of correlation is transformed into Z. Again, this is regarded as parametric test. Now, used to test whether an observed value of R means correlation differs from some hypothetical value and whether two samples value of R differ significantly. Now, we discuss the F test that is used for the variance ratio test, means that can be also called as the variance ratio test. The F test is named in the honor of Professor R. A. Fisher. What is the object of F test? To find out whether the two independent estimates of the population variance differ significantly or not. For carrying out the test of significance, we had to calculate the F. F is defined in this manner. F is equal to S1 square divided by S2 square, or S1 square is equal to x1 multiplied by x bar 1 and divided by n1 minus 1, then we have to get the square. Now, S2 square is equal to summation of x2 minus x bar 2, then divided by n2 minus n1, then whatever we get is required to be squared. Now, S1 square is always the larger estimate of variance, or we can say that S12 is more than S2 square. Dear friends, we have discussed so far three types of the parametric test: the T test, F test and Z test. Now, discuss the chi-square test, and this is regarded as non-parametric test. Tests of significance such as T, F, Z are based on the assumption that samples were drawn from normally distributed population. These tests are known as parametric tests. If rigid assumption cannot be made regarding distribution of population, or we can say when samples has not been taken from the normal population, then we require the chi-square test. So, chi-square test or x-square test is an example of the non-parametric test. So, chi-square test, pronounced as chi-square test, is most widely used non-parametric test is statistical work. Now, what is chi-square test? This is equal to summation of O minus E, that is squared, then this is divided by E. Now, O stand in this case means that refers to the observed frequencies and E refers to the expected frequencies. Now, what are the steps required for determining the value of the chi-square? Now, first we calculate the expected frequency by the equation E is equal to RT multiplied by CT divided by N. E stands for expected frequencies, RT stands for the row total for the row containing the cell, and CT stands for the column total for the column containing the cell, and N that stands for the total number of the observations. Then second step is obtain the values of O minus E, and that is to be squared, and third step is divide the value of O minus E square by E and obtain the total summation O minus E square and divided by E. Hello friends, in this part of the program we have discussed initially the two theorems which are used for calculating probability, that is addition theorem, and second was multiplication theorem. After that we have discussed in a precise manner what is sampling methods. Then we discussed what is hypothesis, what is null hypothesis. Then we have discussed the significance of tests. This is very important because when samples are taken from the universe, then there is always probability of standard error. So, in order to find out the significance of the samples taken is very essential. Now, in this case we have discussed the different tests which are used in respect of attributes, or attributes means any information which is not quantifiable manner, in which we can say that whether there is presence and absence of the characters or attributes. After that, we have discussed the test of significance for the large samples. Then we have discussed test for the significance of the small samples, in which we have discussed the t-test, that is one of the parametric tests. After that, we have discussed the z-test. This is also applicable in respect of small samples, but that is used in respect of correlations. Then we have discussed the f-test, and this is also regarded as variance ratio test. Then we have discussed the chi-square test. Now, this is considered as non-parametric test, and that is used whenever the population is not regarded as normal. Thank you.